So now I've drawn most of them, and let's have a look how the periodic table organizes this. Remember, the key energy level of the electrons is the outer energy level. Electrons in the outer energy level are also called valence electrons. Whoops. Outer electrons in the outer energy level are called valence electrons. And valence indicates that they're going to link with something. But let's have a look at why. Firstly, let's have a look at how the periodic table is organized. So, if we go to a random square on here, 14, we'll notice that is in period 3 and group 4. Don't worry about the A's and the 14s. I'm only talking about 1, 2, 3, 4, 5, 6, 7, 8 here. So yes, period 3 means it has 3 energy levels. Its outer energy level is the third energy level. And then 4 means it's got 4 electrons in its outer energy level. That's how the periodic table works, because the outer electrons, the electrons in the outer energy level, otherwise known as the valence electrons, are the ones that determine what an atom is going to do in a chemical reaction. The periodic table is arranged to accommodate how the valence electrons are. So we go to here, neon. It has 2 circles because it has 2 energy levels. That's why it's placed in period 2. And it has 8 electrons in its outer energy level. Okay? So that's what all this is about. So if I now draw potassium, and you'll notice that I'm going to scrub some things out so I can actually draw it. It has 19 protons, and it has, because it's in period 4, 4 circles around it, because it has 4 energy levels. So there's 19 and K, and here's my 4 energy levels. In the middle one, well, we just count along here, because each of them follows on from the last. What oxygen's got is just 1 more electron than nitrogen. So we draw nitrogen's energy levels, and then we add 1 to make oxygen. Of course, changing the number of protons in the middle as well. So here we are with potassium. First period, 1, 2. So it's got 2 in the first energy level. Second period, second energy level. 8 in that. I'm drawing them in pairs again. Third period. 8. And the fourth period, it's got 1. So, every element in group 1, every element in group 1 has 1 valence electron, 1 outer electron. Every atom in group 3 has 3 outer electrons, 3 valence electrons. Every atom in group 7 has 7 outer electrons. And this is what determines how an atom will react.